Welcome back to my channel. This is Pragya Jain, and today we are discussing our internal test 2 topics. And the first question is, what are the stages of text mining? Consider the example of complaint suggests the approach process to identify applicable IPS and BNS sections. So the answer is, the text mining in the data science involves extracting meaningful informations and insights from the unstructured text data. Here are the key stages of the text mining. So the first stage is text collection. In this, we have gathered the text from relevant sources like websites, database, API, social medias, different PDFs, word formats. The next one is text pre-processing. Once we have collected the text, we have to pre-process it by using tokenization, lowercasing, stop word removal, stemming and lemmanization, and removing special characters. Tokenization split the text into words, sentence, and n-grams. Lowerizing converting all text into lowercase. Stop word removal common words like and, or, the. Stemming and lemmanization involves removal of reduce words to their root forms, and lemmanization reduce words to their base forms using a vocabulary. For example, we have better. So better is the base form of the better is good. So we will reduce better with good and remove special characters like stripe punctuations, symbols, or HTML tags. The third we have is text pre-processing. So once we collected the text and pre-process it, we have to represent the text. So we convert the text format into the number which is understandable by a computer, because computer cannot understand the language we have written the text. So we'll convert the text with the help of these techniques like bag of words, TF-IDF, words embedding, document embedding, and many more. The fourth one we have is feature selection and dimensionality reductions. We have to reduce the features set to improve the model efficiencies. We use techniques for feature selection such as remove low frequency words or redundant features, use dimensionality reduction methods. The fifth one we have is text analysis and modeling. This will include text classification, sentiment analysis, topic modeling, named entity recognition, clustering, and summarization. The text analysis categorizes the text into predefined labels, then determine the sentiments, then discover the underlying themes, identify names, dates, organization, group similar documents, and then generate concise summaries for long text. This whole process is known as text analysis and modeling. Now the sixth step we have is evaluation. Assess the performance of a model or analyze. We have to evaluate our model on different bases and perform different tests such as accuracy, precision, recall, F1 score for testing the performance, and check whether our model is weak or strong and what are its performance metrics. Now the seventh one is visualization and interpretation. Present insights and finding effectiveness. This visualization helps our model to be present in effective manner, and this will help to understand more about our model. You can use Matplot, PyPlot, libraries of Python to use visualization in your model. The last step is deployment. Deploy the text mining solution for the real world use. Okay, so the second question we have given is, give algorithm for the suitable place for the following tasks. Okay, so the first one is data pre-processing. So the algorithm for data pre-processing includes understand the data sets, handling missing data, handle outliners, data type conversions, feature selection, feature engineering, feature selection, handle class imbalance, text data pre-processing, split the data set, save the processed data. So we'll look into one by one. Understand the data sets. You have to understand the data, explore the data, what are its columns, what are the data types, missing values, targeted values. Then you have to handle the missing data. Suppose some column doesn't have data, you have to identify missing values, remove rows or columns with excessive missing data, use advanced techniques like KNN or Mike imputations, impute missing values using statistical methods like mean, median, and mode. Then you have to handle outliers, detect outliers using statistical methods like a z-square, or you can use or you can remove the outliers, transforms the data to reduce the impact of outliers, retain them if they are relevant. Then the fourth one is data type conversion. Convert the data type into appropriate formats, label encoding, one hot encoding, and binary encoding. Then we have is feature scaling. Normalize or standardize numerical features to bring them to the same scale. Then we have is feature engineering. Create one feature or transform existing ones based on the domain knowledge. Combine or split columns if needed. Then we have is feature selection. Remove irrelevant or redundant features. Suppose we have features which are same features, so you have to remove one of them, or the features which are irrelevant to your model, you have to remove them also. Use techniques like correlation analysis, mutual information, variance, threshold for feature selections. Then handle class imbalance. Check for class imbalance in classification problems. Text data processing, tokenization, stemming, lemmonization that we have studied in our previous question. Then split the data sets into training set, validation set, and test set, and then save the process data for further use and analysis. The second one we have is classification. So the algorithm for classification is as follows. First we have to understand the problem, like what are the objectives of it, classification, multi-classification, what are the target values, and so on. Then you have to load and pre-process the data. Load the dataset in your environment. Pre-process like handle missing values, normalization and standardization features. Then you have to split the datasets into training set, validation set, test set. We have done this in detail. We have done the split data set in detail in our other videos also. You can check them out. Select a classification algorithm such as logistic regression, decision tree, random forest, SVM, KNN, naive Bayes, neural networks. So select one in the following of them. Then train the model. Train the selected algorithm on the training data sets. Evaluate the model. You have to evaluate the model of validation of a model with the help of the metrics are accuracy, precision, recall, or F1 square. Then you have to optimize the model. Perform hyperparameters turning using techniques like grid search, random search. Then you have to test the model, deploy the model, and then monitor the performance of the model to retain as needed. The third one we have is clustering. So the algorithm for clustering is to understand the problem, as we have done in any other algorithms also. You have to understand the problem, its objectives, its data sets, features, scale, size. Then load and pre-process the data like handling missing values, normalization and standardization. Then you have to choose a cluster algorithm. Select an appropriate cluster algorithm according to the need of your model, like k-mean, hierarchical clustering, Gaussian mixture models, mean shift. Then the fourth one is to determine the number of clusters. You have to determine the number of clusters you are needed in your model. You can use the techniques like elbow method, Silhouette square, gap statics. The fifth one we have fit the cluster algorithm. Apply the cluster algorithm to the datasets and assign the data points to the cluster. Then evaluate the cluster performance. Visualize the cluster using scatter plots, dimensional reduction methods, and then interpret and use the cluster. Analyze the cluster characteristics and assign meaningful labels if necessary. Use the cluster results for decision making or further processing. Now the fourth one we have is decision tree. So the algorithm for building a decision tree is as follows. First you have to understand the problem, as we have done in many other algorithms also. Then load and pre-process the data. Choose the splitting criteria. For classification, use metrics like Gini index or information gain, or you can say entropy. For regression, use metrics like mean square error or mean absolute error. Now the final step is to build a decision tree. This is the main step of algorithm of making a decision tree, is that build a decision tree. Start with the root node. For each node, evaluate all the possible splits on all features. Choose the split that minimize impurity or maximize information gain. Split the data into the subsets based on the selected split. Create a child node for each subnode. Repeat the process until all the sample nodes belong to the same class. Now, prune the tree. Removal unnecessary branches or cutting out the unnecessary branches to prevent overfitting. Evaluate the tree. Access tree performance on test data using appropriate metrics. Then optimize the tree using techniques like grid search or random search. The fifth one we have is association rule mining. You can say ARM. So the association rule mining, the algorithm for association rule mining includes its item sets, a set of items, support a fraction of transitions containing the item set, confidence, measure of how often the rule X belongs to Y, X is true. Then lift, measure the strength of a rule relative to the random chance. Then load the data. Load the data set of transitions where the transition contains a set of items. Set the threshold. Define minimum thresholds for support, for example 0.1 for 10 support, confidence, example 0.6 for 60 confidence. Generate the frequent item sets. Generate candidate item sets of size 1, C1 and calculate their support. Prune candidate item sets that don't meet the minimum support threshold. Generate the larger candidate items C2, C3 and so on by combining frequent items from the previous step. Repeat until no more candidate items can be generated. The fifth step is to generate association rule for each frequent item set. Divide X into all possible subsets, calculate the confidence and lift for each rule. Retain all the rules and meet the minimum confidence and lift threshold. The sixth and the final step is to sort and interpret the rules. The last question and the third question we have is to give the algorithm for linear classification model for fitting a best linear curve in scatter plot. So the algorithm for linear classification is as follows. First, input the data sets D containing the point x1, y1, x2, y2 and so on till xn, yn, where x is an independent variable and y is a dependent variable. Second is to initialize the variable, compute the mean of x values and compute the mean of y values. Third step is to calculate the slope using the formula. Then calculate the intercept b. B is equals to y mean minus m dot x mean. Then fifth step is to construct the linear equation. The best fit line is represented by y is equals to mx plus b. And the sixth step is the final step if the output m intercept b and the linear equation y equals to mx plus b. So that's it for the video. Thank you.